Today we're going to learn about Concept 12, Day 6 in Geometry. It's all about congruence in right triangles. When you look at this triangle, ABC, it would appear that we have an angle, a side, and a side that we know the measurement of. However, another triangle with the identical measurements could be drawn in a different way. Taking a look at this triangle. Segment BC either swings out far to the right, like it does in the first triangle, or it swings over inside to the left, as it does in the second triangle. That's why we do not have a triangle congruence theorem, angle side side. But what would happen if angle A was a 90-degree angle? Would this make a difference in the way the triangle would be created? Let's take a look. With this triangle, angle A is right. We have a side and we have the hypotenuse. What about that angle on the edge, angle C? Could it be in two different places like angle C was in different places in the two triangles up above? With the right angle at A, it forces every other triangle that has a right angle at A, has a leg that is 5 and a hypotenuse that is 12 to be drawn exactly like this one is. This triangle is a right triangle because by the definition it has a 90-degree angle. What would the other parts of that triangle be labeled other than the right angle? Well, the sides could be labeled legs, and the remaining side could be labeled a hypotenuse. Every right triangle is made up of two legs and a hypotenuse, and the hypotenuse is the side directly opposite the right angle. We now have yet another way to prove two triangles are congruent. We'll refer to this theorem as the HL congruence theorem. It states if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then we can say that the two triangles are congruent. In the example below, if we know hypotenuse AB is congruent to hypotenuse DE, and we know side, AC is congruent to side DF, then we can conclude that the two triangles are congruent. In order for the HL congruence theorem to work, three conditions must be met. The triangles have to be right, the triangles have to have congruent hypotenuses, and the triangles have to have one pair of congruent legs. Let's take a look at some theorems, or proving some triangles congruent. In this example, we're given that side AB is congruent to side CD, and we know that angle B and D are right angles. So I've already marked that in my drawing, and I've listed it as my first conclusion, and my first justification is the reason given. Looking at the two triangles, we see that they share segment AC. Therefore, we can conclude that AC is congruent to itself, whether it's on the triangle up above or the triangle down below. The segment AC is congruent to itself by the reflexive postulate. Now we ask ourselves, as we look at the two triangles, do we have a hypotenuse and leg congruent to a hypotenuse leg of the other triangle? And indeed we do. So our final conclusion is that the two triangles are congruent because of the HL congruence theorem. Let's look at one more proof. In this drawing, we have a pair of perpendicular lines and one pair of sides that are congruent, and we know that I is the midpoint. So I've stated the given, I've marked the pair of sides congruent, and next I'll mark that we have perpendicular lines. But what do perpendicular lines tell you? Perpendicular lines mean that we have right angles. So I'm next going to conclude that angle BIA and angle TIV are right angles because of the definition of perpendicular lines. I also can conclude that segment IA is congruent to segment IV because of the definition of a midpoint. Once that information is marked on the figure, we clearly see that the HL congruence theorem has been satisfied, so we can conclude that triangle IBA is congruent to triangle ITV.